In this video, I'll show you how I designed, built, and attempted to fly my own plane. This is something I've wanted to do ever since I got into this hobby over a decade ago. This is the plane I quote designed. I say that because you might recognize that the design of this plane looks very similar to another plane on the market today. That plane is the drak. Specifically, the mini drak is the plane that I became familiar with from the drak lineup by Right Wing. Two of my friends have owned this plane, and I eventually bought one of these off of one of them. For a swept forward flying wing, I have always loved how these planes fly, but I also fell in love with how they look in the sky. The shape is just so cool and unique, you don't see many planes like it. Until recently, I had thought that the mini drak was no longer available for purchase. However, Right Wing announced this year that a new production run was going to be made available, so they do appear to be selling the mini drak once again. If you find the design of this airframe interesting, please check out the kits over at teamlegit.com. Because of the inspiration for this project, I have been calling this plane the Tiny Drak. So obviously this project is not as much an exercise in learning aero design concepts and coming up with an aerodynamic airframe design of my own. It is more so an opportunity to explore design methods of getting theoretical designs in CAD to work and fly in the real world. For the modeling process, I made a master unibody part first, which was a one-piece model representation of the entire aerodynamic shape. I modeled all features as surfaces as opposed to solids. There was no particular reason for this, however I think some of the surface blend operations might have come in useful, especially in the fuselage. I also knew next to nothing about modeling with surfaces when I started designing, so this project was a great learning experience in designing with surfaces. The drak is actually not that complex of a plane to model. A couple of sweeps take care of the wings. The profile of the fuselage along the center line is a non-complex curve, which can be done with a simple extrude. A majority of the time modeling the aero unibody was figuring out how to blend the fuselage center to the wings, but eventually I was able to figure out something that looked almost as appealing as the original product. When I showed this model to my friend, he got pretty excited. He thought that we should try to produce a real flying model by using 3D printing. I agreed to give it a try. However, I didn't have a lot of previous experience designing a plane to be made with 3D printing. Fortunately, there are a lot of designs for purchase out there that can be used as reference material. Prior to starting this project, we bought a model of a 3D printed P-38 Lightning that was featured on flight test. Since that time, even more streamlined designs for 3D printed planes have hit the market. Eclipson has many very clean designs for sale. Check them out in the link below. One common aspect of these 3D printed plane designs is that they are designed to use a specific method of FDM 3D printing called spiral vase. Spiral vase printing is done by taking a closed section shape and spiraling the nozzle of a 3D printer around in loops until the part is done. There are several benefits to spiral vase printing. Firstly, the nozzle of the printer never has to break contact with the part since it is able to spiral continuously, layer after layer. This means that the surface finish of the part comes out really good. When the printer has to lift away from the part, a small amount of smearing occurs. Small strands will also form as the nozzle pulls away. Another benefit is layer adhesion. Continuous extrusion means that the plastic being deposited is of a very consistent temperature and feed speed. Spiral vase printing does not allow for any infill material, which is basically internal support matrix structures that the printer can do automatically to reduce the density of the prints. Infill can significantly reduce the part weight, however is still not efficient enough to produce light parts for RC planes. This is another big advantage of spiral vase. Internal support structures can be specifically designed in order to provide the lightest, strongest part possible to make a flying model. Let's take a look at how I incorporated spiral vase printing into the design of the Tiny Drak parts. This is the left wing. I modeled it by assembling it with the unibody I had previously modeled, and then importing all surfaces relevant to the individual wing part I was designing. I then added detailed features to set up the specific structures that I would be printing. I have designed this part to be printed with the root of the wing as the first layer on the print bed. I can actually specify an initial length to print as solid, rather than spiral vase, for the first few layers. This gives me the benefit that I can design a single rib at this root section of the wing. This rib will make this section stiffer, but will also make a convenient surface to glue the wing to the fuselage. As we progress towards the tip of the wing, you can see how I have designed stiffening features that still obey the rules of spiral vase printing. Remember that at any print height, the cross-section needs to maintain an unbroken loop for the printer to follow. To add in a stiffening rib, for example, I did this by adding a surface that cuts in from the bottom skin of the airfoil and passes near the top skin, close enough that the two segments will connect when the printer lays down the beads. You'll notice I had to make this internal rib double-walled, so that the print path could return unbroken to the same point along the bottom of the airfoil that the rib originated. Once you get the basics of this print technique, it is actually pretty simple to design parts this way. In the case of the wings, I designed them in surfaces to start, but ultimately converted the parts to solid by making the surfaces into shells that were of similar thickness of the print extrusion. I constructed the fuselage parts in a similar way to the wings, starting by grafting in the surfaces from the unibody aero part, and then adding detail to the models to be able to print in spiral vase. I experimented with modeling the fuselage parts as pure solids, which was different from how I did the wings. Even though the part is modeled as solid, you can still command the printer to look at the outer wall of the model and follow that as its spiral vase path. This can definitely make adding the internal features simpler than using surfaces. So I sent these models over to my friend Brian, and he gave them a rip on his printer. Many trials were done to get the design optimized to work well with printing. Thanks to Brian, an optimal model and print setting state was sussed out. This activity culminated in an initial full functional build and flight attempt. Unfortunately, this attempt was not recorded. The result was not a successful flight, but a short drop to the earth. Okay, so everything mentioned up to this point was done back in 2019. After an initial attempt and failure on the first flight, this design pretty much went up on the design shelf and collected cobwebs until this year, when Brian attempted printing the design for me in a newer LW-PLA filament. Since he basically gave me these parts, and because there was a huge improvement in quality of the parts, I had to attempt to build a flying model of my own. A quick note on the LW-PLA material: this filament is a great option for 3D printed planes. The plastic foams up after extrusion through the printer nozzle, forming a much less dense part than fully solid print resins. It also finishes and adheres very well during the spiral vase printing. I ended up with a full set of parts from Brian, which were printed per the original 2019 design files, but with one modification. The direction, parallel to the wingspan, was scaled up by 150%. The two other axes were left at the default 100% scaling per the original models. This resulted in a stretched airframe, with a much narrower aspect ratio wing. In the end, I think the additional wing area is good to help get the plane airborne. Huge thanks to Brian for the many hours spent working on these prints, both in 2019 and this year. Link to his channel in the description. Before gluing, the parts were sanded to true the joint surfaces up as flat as possible. All of the printed pieces were assembled together with a 2-hour hardware store epoxy. Oh, that's not good. Oh man, way too much of a gap. Holy cow, that was a dumb idea. Hand sanding. Back to that. We have the right wing just set in place with some epoxy. Tack it in place with some super glue. Just a couple dabs of super glue here. And I really don't know how I'm gonna jig up the last wing. That'll be a problem for tomorrow. That's it. Come back for the left wing tomorrow. See ya. Okay. Well, first of all, got my first wing glued on. That dried. Look at that. That looks great. Beautiful, sharp lines. But I went a little bit ham with my orbital sander, which admittedly was not probably the right tool for the job, but I have filled in that gap with some balsa, which was just enough to fill the gap at the front here, and then I just sanded that down so that it blends in, and the fit is actually pretty spectacularly nice. So I'm going to get on with my last glue job here just as soon as I figure out how I'm going to tip this whole thing upwards and balance it up to dry so that the wing just sits at the top there. I'm not sure yet how I'm going to do that, but I'm going to figure something out. I might like tape this. I'll figure it. You'll see it. You'll see it. There we go. Glue joint's looking pretty good. Little gap in the back here, but nothing little micro balloons in the resin couldn't handle. We're getting there. We're gonna have ourselves a plane. So the nose of the fuselage ended up printing pretty rough. I replaced this chunk of plastic with a sliver of balsa wood, which I sanded to blend with the curves of the nose. I wanted to keep this build as light as possible. However, I did decide to add fiberglass reinforcement to select areas. 3D printed parts tend to fail by delamination between the layers, so I figured protecting certain areas would help keep the parts together during rough landings. Of course, all bets would still be off for a full-on crash with this plane. Fiberglass reinforcement was added around the nose extending to the underbelly, and was also applied around the leading edges of the wings. This forms a bit of a D-box with the internal printed ribs to help prevent wing twist. I added some 6K carbon toe to the top and bottom of the wings as additional sparring to make the wing even stiffer. For the fins and winglets, I decided to construct them out of glass laminated balsa sheet to keep them light yet stiff. I made the elevons out of balsa aileron stock. To save weight, I drilled some speed holes. I sanded the thickness down to better match the thickness of the trailing edge. With most of the airframe parts now finished, the plane was looking pretty slick. It was now time to throw on some paint. I was very happy with how easy the material was to paint. The white color is a good base for lighter paint colors, and the porosity of the LW-PLA means that the paint gets a pretty good adhesion to the parts. With the electrification complete, the plane was ready for an honest maiden. We took her to the local sod farm flying club. With expansive acres of treeless flat grass, it's the perfect spot to maiden a sketchy, fast plane. Instead of a hand launch, we opted to bring our plane chucker catapult setup. I had a few reasons to question how stably this build would fly, which meant that hand launching would be especially risky. Okay, so now we're doing the real thing. You actually have to pay attention too, okay?
Oh, okay.
The way this works is, you see we've got our bungee anchor point here. So this gets hooked onto the sled. So every time I launch it, I'm gonna keep it in the track of this pulley here. I'm gonna stretch it, and I'm gonna hook that onto here. And what that's gonna do is it's gonna pull it and launch this thing forward. What we do to trigger it is, if you come over here, to keep it back here where we want it, until we want to fire it. Mike's got this latch thing here that basically just the garden gate, and if I pull that, it's locked in place. You see that? So pull straight backwards this way. That releases it. That's your safety. Try pulling that right now. That's going to prevent it from opening. So the last thing we can do is just a dry fire here. There, get my power stance going. And hook it. Yeah, it should be ready to go. Just pull it straight back.
Ready?
We're ready.
Wow.
That's all there is to it. Easy, right? Do a practice with the plane now. This was my first time launching with this catapult, so we brought another one of my planes to test
Alright,
that it worked smoothly.
This now.
Do it. You're hot.
I'm gonna pull this now.
Pull it now. Easy. And we did it into the wind, so you saw that lift we got? It's just climbing. Expert landing coming up soon. I almost landed on the bungee rails. We got a little GoPro on the launcher this time. That'll be fun.
One, launch,
Nice.
launch.
You gonna ask me what I'm doing?
Oh, sorry.
because the center of gravity on this plane is a little bit close to the wing point here, it really wants to kind of nose down. So I brought these pieces of pink foam. I like the thickness of this just as is, so what I'll do is I'll cut a piece that fits the shape of this. And that's fine. And that'll work. So I'm just using this to line up whether the motor's going to strike it or not. Push comes from here, it's kind of nose down. I think that'll work.
It's ready to launch.
Up, down, right. Pitch up correct, pitch down correct. We are about to attempt the maiden flight of this nano drak. Recently Brian printed it in LW-PLA and you can see it's just beautiful. All of the surfaces really turned out really clean and I couldn't not try to fly it. So that's what we're here to do today. This plane took around, I would say, at least 50 hours to build. We've got a flight controller here today for stability. For power, we're using a 4-cell spinning a F60 Pro T motor, 2550 kV motor, spinning a 4.1 inch prop. Pretty thrusty feel to it, so I think we should have enough thrust to weight to keep it airborne. And to make sure everything goes smoothly, we've also brought out Mike's catapult because I didn't want to have to whip this by hand today. How long will the first flight be? I don't know. I'm guessing 5 minutes, maybe 10. Probably most nervous about nosing it into the ground right after this. It is a bit heavier than some of the planes I have in this size, but not by much. So I think, if we get a good throw, we're into the wind, I'm hopeful we won't have any issues there.
Ready to launch it?
Yeah.
Is it time?
I think so.
All right.
Catapult is hot. I think all systems are okay.
I'm going to touch the propeller. 3, 2, 1, launch!
Too loud.
Sounds good.
Very squirrely. This is only 50% throttle. Voltage feedback. So I'm gonna have to win.
Oh, that part's too loud.
Woohoo! Victory! And don't fall.
Yeah. Well, we flew it. It worked. And it worked really well. It was a little squirrelier than I wanted. that launch could have been better. I actually thought that it was probably not going to survive the launch. Was barely able to pull out of it. I have to probably go a little bit further forward on the CG. Another thing that did not help was the flight controller. I thought I had done a thorough horizon calibration on this, but in hindsight I probably should have checked one more time after I reflashed Mission Planner onto it. In stabilized mode, the plane was definitely pitching down. If you look back at the footage from the launch, I'm pretty sure that's the reason the plane pitched straight down right after the launch. Once I had it trimmed in manual mode, it was actually pretty fun to fly. I do think I have a little bit more overhead for power, so I think I could probably drop in a 6S into this baby and see how she rips. Motor was completely cold to the touch. ESC, I couldn't hardly feel anything either, and I know that this ESC can go up to 6S no problem. All in all, I'm pretty happy with how it went. I'm glad that it survived. But in the meantime, big thanks to my camera woman, my wife, as well as Brian for printing this plane for me after years of it sitting on the design shelf, and thanks to Mike as well for the launcher. It made a big difference. Thanks, guys. Plane's name is Copyrigh, daughter of Drax. I was gonna say son.
Yeah,
It's a mini drak.
it's a mini drak.
It's beautiful. I'm dizzy now.
Fascinating thing.